Hi. So in this video, we are going to see what is the difference between pure non-competitive inhibition and case one of mixed non-competitive inhibition. Okay. So in both the cases, in pure and case one of mixed non-competitive inhibition, the inhibitor binds with the enzyme. Okay. And the binding of the inhibitor in both the cases is irreversible. Okay. So Vmax decreases in both of the cases. So why we already have discussed in all the other previous videos, right? Why it happens? Because if the inhibitor binds irreversibly with the enzyme is lost, right? So if the enzyme is lost, so total enzyme is reduced, right? So if the enzyme binds with the inhibitor irreversibly, the enzyme is lost. So the total enzyme is reduced. So if the total enzyme is reduced, then Vmax is also going to get reduced. Okay, so in both the cases, Vmax is going to get reduced. Okay, but what happens to the Km? Let's see. So we already know this rule, right? So Km is inversely proportional to the affinity of the substrate for the enzyme, right? Okay, so let us see. So pure, in case of pure non-competitive inhibition, the enzyme, let me draw it so that it will be clear to understand. Okay, so let us suppose this is the enzyme. Okay, and this is my substrate. Okay, and this is another place. Okay, so this is my enzyme and this is my substrate. Okay, so the inhibitor binds here. Okay, okay, so this is the inhibitor. See, the inhibitor binds to the enzyme irreversible. Okay, but it does not affect the active site of the enzyme. So you can understand, right? This site is the active site. Let me use some other color. Okay, you can see that this portion of the enzyme is responsible for binding with the substrate, right? So this is what, this is the active side of the enzyme. Okay, active site. Okay, so so in case of a pure non-competitive inhibition, what happens is whenever inhibitor binds with the enzyme, although it binds irreversibly, okay, it does not affect the shape of the active site. Okay, so the binding of the substrate to the enzyme is not affected. Okay, so in this situation, binding of the substrate to the enzyme is not affected. Okay, okay. So what is going to happen to the Km? Km remains constant, right? Because the affinity is not affected. Affinity is not affected. Affinity is constant, so Km is also constant. Okay, as simple as that. Okay, so let's see the other case. Case one of mixed non-competitive inhibition. Okay, I have to erase some portion so that I can write. Okay, so let me erase. Where to erase? Okay, I will try to write here only. See what is happening. Let me draw here. Okay, so in case one of mixed non-competitive inhibition, what happens is, let me draw the enzyme. So let us suppose this is the enzyme, and this is the substrate. Okay, and this is the inhibitor. So the inhibitor binds at some other place other than the active site. Okay, everything is fine. Till it is binding some other place from the active site. Okay, but the problem is, after binding to the inhibitor, the shape of the active site is changed. Okay, the shape of the active site is changed. Okay, the shape of the active site is changed. Now what is going to happen? The substrate is now no more able to bind to the enzyme because the active site has changed. So what is going to happen to the affinity? What is going to happen to the affinity of the substrate for the enzyme? The affinity goes down. Okay, so the affinity goes down. Then what is going to happen to the Km? What is going to happen to the Km? The Km is going up. Okay, so this is the situation. So here what is happening? The Km remains constant in case of pure non-competitive inhibition. But in case of the first case of mixed non-competitive inhibition, what is happening? The Km increases because of this reason. We can see. I will use some other color. So because of this reason, these reasons. Okay. So this is it.